Hello, our topic for today will be t-test for correlated means. Today we'll be discussing about the definition and terms, steps on how to find t, and concluding if the null hypothesis will be accepted or rejected.
What is t-test? For correlated means, it is a test that checks whether there is a significant difference between population means of two groups. When is it used? It is used when two correlated groups or data are compared. So this is the factors of using t-test for finding the correlated means. A. Formulating the null hypothesis. B. Testing the null hypothesis. And C. Decide.
So here's our first example. It is applicable when comparing the results of the pre-test and the post-test administered to a group of individuals. The two tests must be the same. The given level of significance is 0.01 or 1%. Here we have our table, pre-test and post-test. Here we have the terms. D. Difference between XA minus XB. N. Number of observations. SD. Standard deviation. So here are our steps. The first step is to set up and test the appropriate statistics. The second step is to state the null hypothesis and alternative hypothesis. The null hypothesis being there is no significant difference between pre-test and post-test. The alternative hypothesis being there is a significant difference between pre-test and post-test. The third step is to state the level of significance. Our given level of significance in this problem is 0.01 or 1%. If it is not stated, assume it is 0.05 or 5%. Our fourth step is to solve for D, XA minus XB, and for D squared. To solve for D, subtract pre-test from post-test. And for example, 34 minus 45 is negative 11. To find for D squared, you must square the D. For example, negative 11 squared is 121. Step 5. Get the summation of D and D squared. To get the summation of D, you must add all the numbers in D, with ignoring the negative. To get the summation of D squared, you must also add all the numbers in the column of D squared. Our summation is 1185. To find for N, just have to add all the numbers in pre-test and post-test. Step 6. To compute for T, first find the standard deviation. So for our formula for standard deviation, N times summation of D squared minus summation of D squared over N times N minus 1. Then we have to substitute 10 times 1185 minus 77 squared over 10 times 10 minus 1. Our summation of D squared is 65.79. Then find the roots of the squares of 65.79. The answer is 8.11. That is our standard deviation. Step 7. Compute for T. Our formula for T is summation of D over N over standard deviation over square root of N. Then we have to substitute 77 over 10 over 8.11 over square root of 10. Our T is 3, also known as computed value. Step 8. Find the critical value. Our formula for degrees of freedom is N minus 1, and check the table for the tabular value. So our DF is N minus 1. Substitute is 10 minus 1. Our answer is 9. Our CV is 3, while our TV is 2.82, basing off the degree of freedom, which is 9 in the table. Step 9. Make the decision based on the CV and TV. Our decision is the null hypothesis is rejected because the CV is higher than the TV. Therefore, there's a significant difference between pre-test and post-test. So this is the table if the level of significance is either 0.05 or 0.01.
So here's our example number 2. Level of significance 0.1 or 1%. Our given table is before treatment and after treatment. Our null hypothesis: there is no significant difference between before treatment and after treatment. Alternative hypothesis: there is a significant difference between before treatment and after treatment. Next is to find the d and d squared. So this is the given table of the answers. Next is to find the summation of d and summation of d squared and the n, where the summation of d is equals to 208 and summation of d squared is equals to 5376 and the n is equals to 12. Next is to find the standard deviation. So this is our formula: n times summation of d squared minus times summation of d squared over n times n minus 1. Substitute 12 times 5376 minus 208 squared over 12 times 12 minus 1. As d squared is equals to 160.97, we will find the root of the squared, which is 12.69, and next is to find the t. Summation of d over n over sd over square root of n. d is equal to 208 over 12 over 12.69 over square root of 12, which is 4.73, or our computed value. Next is to find the df equal to n minus 1, 12 minus 1 equals to 11. tv equals 2.718, which is CV is higher than TV. So decision: the null hypothesis is rejected because the CV is higher than the TV. Therefore, there is a significant difference between before treatment and after treatment.
So for our third example, the given level of significance is 0.01 or 1%. The given in the table pre-module scores and post-module scores. The null hypothesis is there is no significant difference between pre-module scores and post-module scores, while the alternative hypothesis being there is a significant difference between pre-module scores and post-module scores. Here we have the table for D. We have to subtract 70 from 84 from pre-module scores and post-module scores, and to find for D squared, we have to find the square of negative 14, which is 196. The summation of D is 133, while summation of D squared is 2659, and the n is 10. The formula for standard deviation is n times summation of D squared minus summation of D squared over n times n minus 1. Then we have to substitute 10 times 2659 minus 133 squared over 10 times 10 minus 1. The answer is 98.9. Then we have to find the roots of the squares, which is 9.94. That is our standard deviation. Then we have to find for t, summation of d over n over standard deviation over square root of n. Then we have to substitute 133 over 10 over 9.94 over square root of 10. Our t is 4.23, or computed value. Then we have to find the df. N minus 1. Substitute, it is 10 minus 1. Our answer is 9. Our TV is 2.821 based on the table. Our CV is higher than the TV. So our decision is the null hypothesis is rejected because the CV is higher than the TV. Therefore, there's a significant difference between pre-module scores and post-module scores. Once again, this has been the group for t-test for correlated means.
Thank you for watching.
Bye!